Hi guys, welcome to the 7.1 guided notes on geometric sequences. Okay, so in this video we're going to talk about geometric sequences, and within geometric sequences there's what's a thing called common ratio. So geometric sequences are a sequence of numbers in which the ratio r remains constant. And how you find that common ratio is you're going to divide each term by the previous term. So you look at the second number in the sequence and you divide it by the first number. Then you look at the third number and divide it by the second. And as long as those match, like every single time the answer on your calculator matches after you divide, that means that it is a geometric sequence. So if it doesn't match, it's not a geometric sequence. All right, so let's take a look at some examples. So you're going to look at each of the sequences, take the second number, divide it by the first number, then take the third number, divide it by the second, and see if they have common ratios. So we're going to take 10 divided by 2 and you get 5, 50 divided by 10 and you get 5, so yes, it is a geometric sequence. Then on the next one, 45 divided by 35 is 0.3 repeating, and 15 divided by 45 is 0.3 repeating, so yes, that is a geometric sequence as well. And then we have 18 divided by 6 is 3, 24 divided by 18 is 1.3 repeating, so this is not, because 3 does not equal 1.3 repeating, so this is not a geometric sequence. And then the last one, negative 14 divided by 7 is negative 2, 28 divided by negative 14 is also negative 2, so yes, this one is a geometric sequence. Okay, so for this question, given this geometric sequence, you need to find the next three terms. So before we were taking the second term, dividing it by the first term to find the ratio, which we still need to do, but then after you find that ratio, you have to do the opposite in order to get back the other numbers. So let's take a look at the first one. So we take negative 21 and divide it by 7 and you get negative 3. So in order to find the numbers that come after 63, we have to multiply by 3 each time, because 7 times negative 3, multiply by negative 3. Because 7 times negative 3 is negative 21, negative 21 times negative 3 is positive 63, and so on. So if we multiply by negative 3 all the way through, we'll get the next three answers. So that would turn into negative 189, and a little secret that I can tell you about your calculator is make it easier on yourself by leaving the previous number in your calculator. So when you have negative 189 in your calculator, just multiply by negative 3. And you get 567, leave 567 in your calculator, multiply it by negative 3, and you get negative 1,701. Just makes it easier than having to type it back in again. All right, so next one you're doing 4 divided by 8, which is 0.5, so we're going to multiply by 0.5 each time. So 2 times 0.5, anytime you're multiplying by 0.5, it's like taking half of the number. So half of 2 is 1, half of 1 is 0.5, half of 0.5 is 0.25. And you're done. So the next one, 768 divided by 3072 is 0.25. So if you're multiplying by 0.25 to get the other numbers, 0.25 is 1/4. So it's the same thing as dividing by 4. So 192 times 0.25, or 192 divided by 4 is 48. Then 0.25 times 48 would be 12, and 12 times 0.25 is 3. So the next three numbers would be that. Next one is negative 25 divided by negative 5, which is a positive 5. So we multiply by 5 each time. So negative 125 times 5 is that. Negative 625 times 5 is that. And negative 3,125 is negative 15,625. Okay, so the geometric sequence formula, you're going to use the letter n, and it stands for the nth term, which is what you're actually looking for. So whenever the question asks you, find the 15th term in this sequence, you're going to use this formula. So the formula is a subset n equals a subset 1 times r to the n minus 1th power. So I'm going to show you what that looks like, and this is the key to what all of those things mean. So a sub 1 equals the first term in the sequence. So whatever the first number is, that's what you put in for a sub 1. R just stands for the ratio, and you find that, remember, by dividing the second number by the first number. Then n is just the term you're looking for. So like I said, if you're looking for the 15th term, you put 15 in for r. All right, so let's take a look at an example. It says, write the rule for the sequence and then find the seventh term. So we have 3, 9, 27. So the first thing you have to do is write down your formula to find the seventh term or any term. And remember, a to the nth is just what your answer is going to be. A subset 1 is the first number in the sequence, which is 3. R will be the common ratio. And then again, n is going to be 7 this time because that's what the question's asking. So we have to find the common ratio, so we take the second number, divide it by the first, and you get 3. Just to test it to make sure this is actually a geometric sequence, we're going to do one more. So 27 divided by 9 is also 3. So 3 is your common ratio. Then remember, like I said, subset 1 is your first number, which is 3 in the problem. You can see that right here. And your common ratio, again, is 3. That's just a coincidence with this problem. They're not going to match most of the time. And n is the nth term that they're looking for in the question, which is 7. So now you just take those numbers and you plug them in where they go in the formula. So a subset 7 is what we're looking for, equals the first number, which is 3, times the ratio, which is 3, raised to the 7th minus 1th power. So then you do 7 minus 1 first, because we do exponents before multiplication in PEMDAS. Then you put in your calculator 3 to the 6th power, which is 729. Then you multiply by 3, and you get your answer of 2,187. Okay, and this one, same thing. We're going to remember our formula to find the geometric sequence, any term in a geometric sequence. So first you have to find the common ratio. So we're going to divide 20 by -4 and get -5. The first term is -4. So we just plug in into our formula. So a to the seventh term, a subset 7th term, equals -4, because that's the first term in the sequence, times your ratio, which we found was -5, raised to 7 minus 1, because 7th is the term that we're looking for. Then we're going to subtract 7 minus 1. Then we're going to raise -5 to the 6th power. And then we're going to multiply it by -4, and your final answer is 62,500. All right, so with this one, we've got 400, 200, 100, so that means our common ratio is going down by a certain amount, so we're going to have a number less than 1. So when we do our formula, we find out what the for a subset 1 is, which is 400. Our ratio would be 200 divided by 400, which is 0.5. And then our term we're looking for is 7. So we're just going to plug those in. So we have a subset 7 equals a sub 1, which is 400, times our ratio, which is 0.5, raised to the 7 minus 1th power. Then you're going to subtract 7 minus 1 and get 6. Then in your calculator, put 0.5 to the 6th power, and then multiply it by 400, and you get a sub 7 is 6.25. All right, so we're going to try something new on your guided notes. I want you to complete this one on your own, and I will be checking when we do our guided notes, checking for grades. I'm going to be looking to see if you completed this one on your own. So go ahead and do this one on your own, and good luck. Go Seahawks. Woo!